to the Ellen MacArthur Foundation's Disruptive Innovation Festival 2019. The festival is an interactive online event series aimed to shift mindsets and inspire action towards a circular economy. Today, in this session, we will be exploring what would Earth look like if we could see Earth through the eyes of an astronaut. My name is Rob, and I'm delighted to be joined by Radu Juaju, the Circular Food Systems researcher at Semilla Ipstar. I'll invite Radu to kick things off shortly, but first, please remember that this is an interactive event, and so any questions or comments that you may have, post them in the comment box to the right of the stream, or alternatively, post them on Twitter using #ThinkDiff. Thank you for joining us today, Radu. Could you share with us an introduction about yourself and what led you to the circular economy and space field, please?
Sure, Rob. Thanks a lot. I'm thrilled to join the Disruptive Innovation Festival for Ellen MacArthur Foundation. So just to set a bit the context, I would just give a bit of background about how I arrived here, working in the space industry. So I was doing my PhD on plant science, and in this PhD, I was studying how environmental parameters such as temperature or nutrients or water are influencing the plant production, but most to qualitative aspects such as vitamin C or phenolics. So not really to yield or production. And I was a bit intrigued by this because a lot of what industry is focusing on is the yield. So I was looking for a context where my research questions and my curiosities had more sense. And then I thought, when you speak about space exploration, it's not enough to produce enough food for the demand of the caloric intake per day for astronauts, but you also have to have the best nutrition of the plant products. So then I went to a conference organized by Melissa, and there I understood that this food production or plant cultivation is just one element in a system, in a closed loop system. So I got more intrigued, and later, funded by the Melissa Foundation, I could do my postdoc in exploring these circular systems developed for space, but mostly how we can translate and transfer technology for applying it here on Earth.
Awesome. Thanks for that, Radu. Could you mentioned the Melissa Foundation. Could you dive a bit into what that is for myself and the audience? Give us an idea of what you get up to with them, please.
Yeah, sure. So Melissa Foundation is foundation from the Melissa Project, which is established to fund PhDs and postdocs to do their research work that is in sync with the objectives of the Melissa Project. So just to give a bit of a background for the Melissa Project, I will share a short presentation. All right. So the Melissa Project's concept is founded on a lake ecosystem, where there are a lot of interaction between the organisms, the bacteria, the plants on different levels. And the bacteria is decomposing the waste produced in the lake, so the elements are used as nutrition for the plants. And there are a lot of exchange of materials and gases and liquids. And all this knowledge, because we understand how this lake ecosystem works, is then translated through technology into a closed loop for sustaining life of the astronauts for long-term space missions. And what that means is that the crew is the one that produces the waste, and then the waste is degraded in 3 different compartments with different technologies that are mainly biological systems. And this degradation of the waste is actually revaluing it into nutrients for cultivation of the plants. And the plants are both source of food and oxygen for the astronauts, and also the water is recycled in this process. So basically, in simple terms, the waste is valued as nutrients and water for sustaining the life of the astronauts, but also energy can be recovered from there. And the aim of Melissa is to characterize all these compartments and model everything in that they really come to an artificial ecosystem that works in a resilience way, just like the natural one that it's based on.
Thanks, Radu. And so all four of those compartments are within, just to clarify, they're within one big machine, right? One big life system. Is that correct?
Yeah, well, there are many organizations working in this Melissa project. So it's a project that is under European Space Agency, and there are organizations, research institutes, universities and companies all over Europe and Canada working on it. And all of these organizations are focusing on each of the compartments individually, because we have to really understand the complexity of each of these systems. And then they're also trying to model and link them together and see how much they can optimize all these mass balances in order to sustain life and also mitigate all the risks that can come with that. And it's designed for a 1,000 days mission for 6 astronauts, just to have this context so you can better model the systems. And there is also a ground demonstration in Barcelona, Melissa pilot plant, where the crew is formed out of rats that they produce CO2 that is then fed to the algae, and algae produce back oxygen for sustaining the life of the rats. So that's already, so to say, more compartments linked there to sort of demonstrate and generate more knowledge and see where we have to work more in doing research to see how we can couple this. But in the end, the goal is to have this kind of artificial ecosystem composed on different systems and machines and biological systems on interplanetary missions, such as going to Mars, and then you have to sustain the life there. So you would have to have all these compartments, and you would have to be relying on them and on their resilience in order to sustain your own life as an astronaut.
You mentioned the pilot plant. How long has that been running for? Has that been a long-term project?
Yeah, it's already since a couple of years. I don't know exactly, so I don't want to say something wrong, but yeah, it's an ongoing project, and the goal there is to demonstrate here on Earth, because we have a bit less constraints, and then we can extrapolate what that means for the space application. And indeed, it's an iterative project in that more and more compartments are linked, and more flows are circulated in the system in order to come to that main objective of having this closed loop system for sustaining life.
Great, thanks, Radi. So it sounds like it's all going pretty well with Melissa project. What are the plans for developing Melissa further from now?
Well, Melissa is already going on since 30 years. So you can imagine that during this period, a lot of know-how was generated and a lot of technology was developed for this purpose of space missions. So Melissa is going on with this mission of developing the system, of closing the loop, of understanding very well how all these very complex interactions between different organisms in order to stay in life will happen. So Melissa is very actively working on that. More and more partners are joining forces in developing this. And in the same time, and this is where my work is focused on, we are trying to apply that know-how and that technology for Earth. Because if we manage to develop this kind of know-how to survive on Mars, because that was my provocative title of the talk. If we can survive on Mars, where we have way more constraints than Earth, and we should be able to use some of that know-how and some of the technology here on Earth to just improve our life or thrive here.
Okay, yeah. So the next question that I was going to go for was sort of why Earth when you could push out to Mars, but you kind of answered that there. But could you develop on that potentially a bit further, please?
Sure. And in preparation of this talk, I was a bit looking how these two sort of streams, let's say circular economy and the Melissa concept, developed during the years, and I tried to see where they interjected. And it was very interesting to stumble upon an essay from Kenneth Balding from '66. He's an economist who kind of started to think about the circular economy, not necessarily in that term, but about a different economy from the linear one. And I will just take a small fragment from it I would like to read, because I think that shows really the overlaps of this space exploration to Earth application. So what he said in his essays that the closed economy of the future might similarly be called the spaceman economy, in which the Earth has become a single spaceship without unlimited reservoirs of anything, either for extraction or for pollution, and in which, therefore, man must find his place in a cyclical ecological system which is capable of continuous reproduction of material from even though it cannot escape having inputs of energy. So that basically really puts it nicely of why it's important to develop these technologies for space and why it's important to use that framework here back on Earth. Because I think when you are thinking about space exploration, you have to think of a lot of constraints. But these kind of constraints are the ones that are driving innovation and are pushing further the science and technology. Because you have to respond to them, you have to be ready to address them. And you have reduced gravity, you have other issues of confinement of the space. You have to deal with the waste. You have no resources like here on Earth. So you have to manage all those aspects in order to sustain the life there. But here on Earth, we are a bit more relaxed, and a bit more flexible about it. Although we also don't have unlimited resources. So we should maybe try to refer to Earth maybe as a spaceship, in that we should be, if we have the know-how to produce value out of waste, we should apply those technologies here on Earth, and we should not be so exploitive. And this links very well with the circular economy principles. We have to design out waste, then we have to regenerate natural system, and this is all principles that are also very well embedded in the Melissa concept.
Awesome, great stuff. And so you've spoken about how why it'd be great to have it here on Earth, and how we could develop a spaceship on Earth. But what are the main barriers to stop us from having already done that or doing that at a greater level right now?
Yeah, that's a good question, because I was from the beginning intrigued with this. From the early stages of my involvement with Melissa, I thought this is really a great concept. This is a really innovative approach to food production, especially. And why is this not going on everywhere on Earth? I think one of the reasons might be that Melissa doesn't have the exposure that it deserves, because you can imagine, as it happens in many cases, that scientists are very focused on their scientific objectives and not so much in communicating to the other world of how this can be applied here and there. So I'm really happy to work with Semia, which is the company from the Netherlands that's mandated to transfer the technology, because we really can make this bridge from the scientific output to actually how would that refer to the actual markets. The other thing is that you might think if you translate a very complex space technology to Earth, might be a bit simpler. You don't have to deal with the reduced gravity, for example, or with the radiation or with the confined space. But in a way, you have to deal with other rules here and the rules of the market. And right now, the areas where the Melissa is really working in, which is water treatment, nutrient recovery, food production, vertical farming, and things like this. These areas are still working based on the linear models. So I think there is one of the main barriers, there is need of a lot of policy changing in order to facilitate things like nutrients recovered from waste streams to enter the market easier. And I was studying these policies a bit to see where are we standing on, and there's a lot of progress being done in the last years coming from the European Commission. There's a lot of innovation there in the policies in kind of facilitating the framework, so these kind of technologies would have a better chance in competing with existing resources, because if you are recovering nutrients from a waste stream and you're trying to compete as a fertilizer with the industry that is exploiting mines, it's very difficult to compete on the economics, because these exploiting industries are very much subsidized. So these kind of things have to change from a policy point of view in order to facilitate these innovative systems come into play.
Sorry, Radu. With the European Commission policy, the policies that you're talking about just then, are they currently in place now? Sorry, I didn't quite catch. Are they in place, or are they going to be implemented in the near future?
So there are some directives, even from the 2015 one concerning circular economy, where there are a lot of things highlight about the recovery of water from waste streams and recovery of nutrients from byproducts. And then on 2017, I think, was an iteration of that, looking at what was happened in this time, and then it was a bit more enforcement into how these nutrients recovered from waste streams can be used, and they actually started to give some standards that would help also the ones that implement these technologies to have the metrics in order to see that you come to a good product that can be safely used. And also looking more going a bit more locally, so to say, in the Netherlands, there's also a lot of policy changes like that. And one of them says that there are 35 waste streams that normally are disposed. And if you have the potential or the know-how or the means to recover anything good from that, you're not allowed to dispose them. So that creates an economic opportunity for these kind of technologies that have the potential to recover value out of waste. And then, of course, you go even more deeper to the city levels, where more and more cities, as you know, as MacArthur Foundation is involved with the food initiative to make roadmaps for circular economy, where food is a strong component, and food is used as a leverage for this transition. And looking at circular food systems and looking to the whole system of producing food, it creates opportunities, and it highlights the gaps in the value chain. It highlights the gaps in how we use resources and what we can do better in that, and also in the waste management, because around 20% of the municipalities' budgets it's wasted on waste management, where that can be better used for actually improving the sustainability of the city.
Awesome. And linking to cities, then, have you got any examples of positively implementing the circular economy's tech that you've learned from the knowledge gained in space and Mars development? Have you seen any of that on Earth currently?
Yeah, there are already different stages of this technology applied on Earth. We just today finished a study, also supported by European Space Agency, which aimed to assess the feasibility of the Melissa technology for helping the cities transition to circular economy. And this study is based on using the waste streams from the city, the municipal waste streams, recovering the nutrients and cleaning the water from them, and using them as resources in food production, mainly controlled environment agriculture, vertical farming. So we looked at the requirements for producing food. In this case, it was for Amsterdam. And we looked at the requirements that are known for four candidate crops, which were tomato, cucumber, lettuce, and pepper, because we know very well the nutrient requirement per kilogram or per square meter of production, and the water requirement, which are the main resources that we try to see if we can bring them from the city, not from outside the city. So, and then we looked at the waste streams that are produced in Amsterdam from households and per person per day. And then with the Melissa technologies, we could model and calculate how much nutrients we could generate from these waste streams and how much water we could clean and use in the irrigation of the crops, and also how much energy we could recover. And one of the main outcomes from this study is that actually from the nutrients and water point of view, we can produce around 150 to 300% of the requirements that these crops need per kilogram. So just to give an example, you could produce around 2 kilograms of tomato per person per day of waste produced. So that gives a bit of overview of what's the potential there. And of course, there are a lot of things that has to be discussed about the scalability of the systems and about the implementation of them. There's also decentralized systems for waste management and recovery. So yeah, it's still a lot to discuss about this study, and the next step is to start some proof of concepts with the city of Amsterdam, and not only, because this is really a framework that we can use to all the cities that are interested to apply this kind of technologies. We went first to the city of Amsterdam because of its known strategy for circular economy, and they have a lot of new developments where they have strong involvement of circular principles in these new households, and there is an opportunity there. But a lot of cities could benefit of this of these calculations of these feasibility studies of how the Melissa can actually help them recover a lot of the resources they will need to produce food in the cities from the wastes of the cities.
Lovely. And did you manage to gauge an acceptance from the population of Amsterdam on whether they would be as a whole keen to implement this great project you've got going?
That's such a good question. I will go back a bit to Earth applications to give you an example of the people accessibility. So Semia also have a spin-off called Semia Sanitation, which is a company that developed a shipping container that contains toilets for men and women. And then on the other part of the container is it's a unit that treats the water, recovers the nutrients, and cleans the water in order to produce food. And we went with this container to festivals in the Netherlands, because festivals are really like villages where there are a lot of people, high density. They donate a lot of the waste in these containers, so we could do a lot of research based on this input, so we could optimize the system, we could see how efficient it is, and so on. But one of the things that we didn't expect was the outcome of the acceptability informal questionnaire, so to say. So of course we had a lot of discussion explaining the technology, and a lot of people, their first reaction is they would not like to eat food that is grown based on nutrients coming from their waste. And maybe it makes sense. People are concerning about their safety and their health, and I think that's good. But what was very interesting is that I always in this discussion ask them, okay, that makes sense and I respect that. But do you think that an astronaut on Mars should use his own waste in order to make resources for producing food? And everybody was in favor of that. So everybody was saying that, yeah, that makes sense. They need that because they don't have resources, they don't have water, they have to recover everything. And I said, okay, but if they in that case, they have to do that, why do we have to think differently about our situation on Earth? Just think of all the issues that are now very hot topic with climate change and the phosphorus peak that we are reaching, and the depletion of resources, and the ways that it's actually damaging the environment. They're all things that can be addressed in more circular way. If the waste is actually damaging the environment, then we have to really put a lot of treatment into dealing with that. If we have the know-how and the technology to recover value from that, why not doing it? It's not a question about if we should do it or if it's safe enough. Of course, there are issues that have to be addressed in this research and these prototypes that are going on right now. But it's definitely something that we should go on and work with, because it's a huge opportunity to have a better impact in the environment.
Sounds great. Thanks very much, Radu. I'm just going to briefly sidetrack a little bit here to what we were talking about before. We had a question from David from the audience, who's asked, I just learned about the Melissa project. You're very right about spaceship economy, but why is space ecology not more visible in the general green movement?
Well, I'm not sure if I'm able to answer to that. I think maybe people dissociate space exploration from Earth problems, because some people might look at space exploration like a solution of running from Earth to make humankind survive. And in that sense, maybe they think it doesn't have a part in this ecological movement or solutions for helping the Earth. But I think there's no debate in how this space exploration or developments there could help the Earth. And in turn, what is very interesting is that we can use that space technology, or whatever you want to call it, on Earth to try to make our lives better. But in the same time, we showcase or we test here in a more safe way these technologies that actually give feedback to the space industry in learning a lot of things about how this will play out in the future. So it's really a feedback loop from this space and Earth are not so dissociated of how people might think. And having this dialogue all the time and really framing Earth more from this perspective of constraints, of being more self-sufficient and resilient, would help bringing space exploration as a solution in the ecological movement.
Great. I hope that's answered his question there. Thanks for that, Radu. And then, so if we're going to try and bring it closer to home, do you have, I mean, you've already mentioned 2 examples of positive implementation, but I'm just wondering, do you have any more? Because they sound pretty incredible.
Yeah, sure. We are also working on a European funded project, Horizon 2020, called where the Trappist brewery La Trappe from the Netherlands is one of the case studies from this project, where the aim is to recover the water for fit for use for the brewery. So the waste water coming from the brewery is used in a metabolic network reactor, which is basically a greenhouse where plants in a sort of hydroponic system are cleaning the water, and there are also artificial roots that help the microbes settle there and do this treatment of the water. But the effluent is still not at the quality ready to be used back in the brewery. So then here it comes the space technology to reach to that level. So what we do is we are using Melissa technology of growing purple bacteria, which is the bacteria that can be cultivated on these waste streams, and it actually fixes nitrogen, and then it can be used, the biomass harvested from this process can be used as slow release fertilizer for the plants, or can be used also for feed for fish or poultry or other things. And then the rest of the water is still treated through a process of different membranes, and it can also reach to potable water, but the aim in this project is to reach fit for use, so it can be used back in the brewery for washing or other processes in the beer making.
Do they by any chance use that purified water in growing the hops and the grains for the beer, or is it, like you say, for washing bottles? And
so yes, it depends really on the technology, how far you are pushing the water treatment, because you can recover a higher percentage of water to a bit lower level of quality, enough to be used in washing. But if you need to use this water in the production, and you have to implement some design that reaches that level, but you might lose some some percentage of the saving of the water. But it's very important to say that from this outcome, it's also the concentrated that is coming out from this treatment, and that can be fed back to the purple bacteria or back to the first reactor. So in a way, we are really looking at ways to have no waste generated there and try to use everything back. And this is one of, I think, the main advantages of the Melissa loop concept, because although it has all these compartments, it gives a lot of flexibility with design here for Earth applications. And I saw in this study that we are really looking to different waste streams, the black water, yellow water, gray water, which technology can work best with which stream, and where we can optimize on, for example, recovering nutrients, and where we can optimize on water recovery. So then we can design a system that brings the best out of all the worlds, and then really try to reach a zero waste strategy.
And then we've got a question from the audience again. I know this might not relate so much to yourself, Radu, as a circular food systems researcher, but they're asking, is there any movement towards a circular economy for the harder materials that are involved in space, such as the metals of satellites and the more technical cycle?
Yeah, indeed. I'm not sure I'm qualified enough to ask these questions. I'm sure that this kind of approach about circularity is on all sectors. And as I said, the Melissa concept is a highly biological system, but still these hardware components are important to be also thought in circular way. It adds an extra layer of complexity, I think, to the whole approach. There's still a lot to be learned and studied and researched in just the core science objectives of the Melissa loop of how these systems work, and to reach the best knowledge possible to optimize them. But definitely that should be also included in the new developments.
Lovely. Thanks very much, Radu. And then I think one more sort of question that we've got going on here is, how much manpower does a Melissa plant require? Is it quite labor intensive, or would you say that once you put the inputs in, it just like self-sustains itself, which I guess is the aim? But
yeah, indeed, that's the aim for the systems to be fully automated and autonomous. So there should be no reliance on manpower other than monitoring and being sure that everything goes well. Melissa pilot plant being a very scientific oriented endeavor, it has researchers that are working there on a daily basis in getting all the data and getting all the know-how out of the systems. But also the ones that we are designing for Earth applications, we are really looking at the automation aspects and ICT to just facilitate that automation level that it needs in order to be well implemented and not need that much man involvement, just because would help a lot with stabilizing the system. And yeah, it always needs some manpower in terms of monitoring and being sure that everything goes well and optimizing, but the aim is to be very much autonomous.
Cool, great stuff. And one more question from Michael is asking, you've got the policies coming in now from the European Commission. You have some private sector support, it would appear, and also city-based welcomings through Amsterdam and the Netherlands. But how would you say there's a significant amount of private sector experience and sort of willingness to cooperate on this angle? Yeah,
definitely. There are many organizations coming from the private sector in the Melissa consortium. There are many companies partners in this project, and also Melissa is more and more developing spin-offs based on the on the knowledge, on the technology, on the science. There are definitely a lot of opportunity for companies to work in this sector, and I think they're coming more and more. But there's a very important component of the private sector involved in this Melissa project.
Great, thank you very much. I think you have touched on it already, but just to clarify for some of the audience, we do have another question again from David again, who's asking, are the space food technologies already applied on Earth, for example, in the Netherlands, in Amsterdam, or was it just research based?
It's a step-by-step approach. There are some examples of applications on Earth. There's the need to go from the lab experimentation to a pilot, to a demonstration case, and so on, to be able to scale up. But there's, for example, in the Concordia research station in Antarctica, there is a Melissa technology that deals with all the waste produced there, from the kitchen to showering to recycling all the water. So that's one example how where it's applied, and there are a couple of examples like this all over the world. And in terms of, for example, this study that we did, it was exactly how to just have an overview about the feasibility, the technical feasibility of this technology, because working on the data and modeling can give us some predictions about what the output will be. And then the next step is to have some pilots to validate those outputs. Once you have that, then you can easily start implementing them where the opportunity arises, because then you have a higher level of confidence that these systems work like that, and that's the prediction. And you can make business models based on that, because that's very important to showcase the economic opportunity that this technology brings.
Great. And so you'd say the upcoming aims for Melissa and similar alike is to start implementing these pilots and the research and everything that's going on.
Yeah, definitely. That's one of our goals here at SEMIA, to use this technology and transfer it for Earth application. That means from applying it to different kind of sectors. The brewery one was one of the examples where we can validate the technologies from Melissa, so then we can extrapolate to all the breweries that need to become more circular and save some resources in the process. And that's what we are doing. We are running pilots and demonstrators and working with companies and industries that are willing to apply these technologies in order to become more circular. And cities having these strategies of becoming circular, and especially food being a big component, we can definitely show that these technologies have the opportunity to recover some important resources for the food production, which this is my main interest in. I think it's a really huge opportunity and also really fun to work on. But there's a caveat there that I would like to say, that one of the also outcomes from the study is that we really need very well-structured data in order to be able to have, as I said, a high level of confidence about the system. So I think that's also an opportunity to discuss with the cities and other stakeholders about what kind of metrics they need to follow in the cities, and what kind of data they need to gather in order to accelerate this transition. Because if they don't have enough data that actually helps us model, for example, how this system will play in different sectors, it's very difficult to predict the outcome. So you might implement a technology with not expecting results, which would be detrimental for the following steps. So that's also a very important thing. And again, going back to the space exploration, when they design a mission, they have to think of everything that you can imagine can be measured. So in that way, it gives a framework about the data points that are important for these systems. So with this framework, we can come back on Earth and say, we kind of need this data, and let's see what's possible and what have to be changed in order to collect the data, and then also share it for the different companies that want to be involved in these projects.
Great. Thank you very much, Radu. That seems like a pretty reasonable place to call the session. It's been great fun, and thanks very much for that. Very insightful. And I hope the viewers have enjoyed this session as much as I have. It was great. It's been great to hear about all your work, Radu, and all the projects that's been going on and you're involved in, as well as the opportunities that this work presents to us today and for our future. I'd like to thank you, Radu, for taking the time out to talk to us today.
Thanks, Rob. It was really fun.
Yeah, it's been great. It's been awesome. And yeah, thanks for just providing us with the knowledge that the Earth has the potential to move from linear to circular ways of thinking and operating. It just requires a simple shift in mindset, a bit of help from technology, and going back to our natural roots and processes found in the very own spaceship, the Earth. If you still have any thoughts you want to share or questions you want to ask, or if you are even watching this recording of the session, we still want to hear your comments, questions, and feedback. So please use the comment box to the right of the session page to leave those comments, and hopefully Radu could even answer a few of them depending on what the quality of the question is. And please, if you are still interested, there is a really great session going on at the moment titled Reimagining Reuse. And then after that at 5 p.m. there is a Love Not Landfill and Where Next session, how London and New York aim to make fashion circular, on the final session of the November 2019 DIF. Massive thanks again to Radu, and remember to catch up on anything we've missed or that you're interested in. Visit thinkdiff.co.